John Todd speaking, and he's one of the team that was working on living machines in the 60s and 70s. They formed a group called the New Alchemy Institute, as opposed to the medieval alchemy, which was the beginning of modern science. And the New Alchemy Institute they named because they want to bring in a new age of using natural systems in our technologies. So that they were into a whole lot of interesting things. Living machines was one of the things that came out of it. So, for example, in some of the plants you saw, it could treat either sewage, which is just what comes out of the toilet straight, which is a mixture of inorganic material, wastewater industry, some surfactants, which are soaps, basically, solvents, and heavy metals like lead or cadmium or silver, zinc, copper, mercury, and carcinogens like toluene or methylene chloride or trichloroethane, and also a mixture of bacteria and viruses. And so the living machine is able to digest and deal with each of those things with the mixture of organisms that we set up there. It can also deal with septage, which is, as opposed to sewage, it's a much more concentrated form. Like, for example, a house that has a septic system, all what comes out of the toilet goes down into the collection area and it becomes concentrated as the water flows out. And septage is left, which is about 30 to 100 times more concentrated than sewage, so it's very difficult to treat in other ways. So if either sewage or septage is dumped untreated into natural systems, which we all know is a bad thing, and we're trying to treat it in some ways with conventional treatment. I'll give you a comparison of conventional and solar products in a second. If it's dumped into the food chain, then the contaminants are extra damaging as it goes up the food chain, which is interesting. Like if it's generally present in a pond or an environment, then as each link in the chain eats the lower levels, then there's fewer and fewer members up the food chain, so all the contaminants get concentrated instead of something we could be concerned about, since we're often at the top of the food chain. But also in disturbing natural ecosystems, it's often the predators that keep the ecosystems healthy, and that the primary producers don't become overabundant, or anyway, in order to keep the balance, so it's good to have healthy predators. Let's see. So in a living machine like this, John Todd and Nancy Todd and Bill McClarney, they included over 1,000 species of different plants and animals and protozoa and bacteria, and they collected them from all over the world. So it's interesting, Steve was thinking about whether it'd be better to, if we were to design something similar, it'd be better to choose local things which would work well with the local environment, and that's a really good idea too. But it's interesting, I think he was selecting plants and fish from elsewhere because they have had special talents for cleaning up a particular toxin.
Also, they don't go dormant.
Yeah.
Sorry to interrupt.
Yeah, that's okay. Yeah, feel free to interrupt with other ideas and things. Yeah, and so in this controlled greenhouse area, it can be at a warmer, stable temperature all year long, and so maybe that's another good reason to include some of the more tropical species. So they can digest the nutrients and break down the harmful chemicals and carcinogens, and actually one of the references said that the system got rid of 99.9% of the toluene just from digesting it from the bacteria and the algae. Let's see. Yeah, and it's good to have the translucent tanks because then it can absorb as much light as possible and have a three-dimensional environment for and have lots of aeration and mixture to keep things moving.